All right, good morning, everybody. I hope you can hear me loud and clear. My live audience, how are you doing? Good morning this morning. Good. Um, so again, welcome to another episode of Breakfast with Data, and this is our deep dive with DataFrame series, where we look at the different characteristics of a data frame. We are looking at Pandas data frame and PySpark data frame side by side. Yesterday we were able to touch on how you filter rows, and one of the important thing we saw is that when you're filtering, you need to make sure if you're doing your filtering on a nullable row, you need to make sure that that is well um, accounted for. Without further ado, we're going to jump into today's session, and we're going to try and see what happens when you try to add column. So sometimes you need to have a derived column. Okay, so in some cases you need to have a um and that's what we are going to be looking at today in Pandas. How do you add an additional column? What is the equivalent in um PySpark, right? Let's say, for example, this our um the grades CSV that we were looking at yesterday. Let's say we want to make some decision, maybe remark as to who has passed, who did not pass, and all those kind of stuff. How do you do that in Pandas, and how do you do it in PySpark? To start with, we will need to first import. Um, we need to import pandas pandas as PD, like we always do, right? This is the first thing, and I'm just going to use this. Let's open the catalog in a new tab so that I'm able to copy the URL of where your uh data frame is. In mine is in a volume on Databricks, the free edition here, where we call raw. So I'm going to go here and I'm going to copy this path. So this path could be anywhere on your estate. It must be something that you can reach via Databricks. It might be an external location actually. So what we are going to do is we are going to do our df. Let's call this one grades, right? Because it's grades, right? And set it equal to pd dot read underscore csv, and we are going to set this to this particular URL. That will read the URL for us, and we can quickly look at um um can quickly look at grades. We can say um um let's just say grades dot add or dot sample. Let's sample 5 from here, and I'm going to wrap this in the display so that I'm able to see this display. And if I run this now, I should get the full just 5 random sample and have the full picture of what grade is. And here I want to say if someone passed or if they did not pass. So in Pandas, this is running. Let's just highlight. Okay, it's run. So let's say I want a new column, right? And I want um I want a new column, and that column needs to do some calculation. So for example, let's say df, I'm keep on using df. Let's use grades and say grades, right? And I want to add a new column. I can add it by direct assignment to the data frame, right? So I can do this and say past, right? And I can set it equal to uh grades, right? And I use a condition grade. Let's make this look neater. Grades, grade. This grade column is what we are going to. So in other words, this is called a derived column, right? Because we derive it from adding from another column that is already existing. So it might be some logic. It might actually be a case statement. When something is something, we try to do something. So if we were to look at this, let's take another sample of this again now, right? And see what would have happened here. Can you see that now this modification, it returns a new data frame. This is actually a new data frame, but it assigned it to this same name. Now, this is why you have to be careful when you are using direct assignment, because with direct assignment, you alter the old data frame. It's a trick way. It's actually a new data frame that gets assigned to that overwrites the old data frame. If that makes some kind of sense, right? And you will see that this is a boolean, right? So you don't always want to do this, right? Depending on what you are trying to achieve anyway. You understand? In a lot of cases, let's go back to this guy and run this again, right? And not use the direct assignment. There is a way that we do another there is another route to do this instead of doing a direct. Let's say we want there's another pattern where we return a new data frame, and we can use chain, right, to do it. So what do we do? Let's create a new data frame called result, which is the right approach to be doing this, right? Always put things in separate data frames. It's the data frame for transformation. Always remember, data frame is just like a memory table, right? It's until you want to write it that you now materialize what you are doing. And it's always a good thing to keep a copy of your raw as much as you can. So we can have this result be grades, right? Dot assign. There is this assign method of Pandas data frame. We are going to see the equivalent in PySpark. The equivalent is with column, but we are going to get there. And I can say past, right? And I set it equal to grades, which is our data frame. And I'll pick the grade column there. Grade, right? And I'll say greater than or equal to 50, right? That will be the first comma. And I can have let's say I have another column inside this. Let's do maybe grade square. And let's say, in fact, let me go to the next line and do grade squared, which I'm not sure it makes sense, but if you want to do root mean square, or something. Grades, right? And we can have grade, right? Whatever is there. And we all know how we do square in Python. We can do this. And then we can have grade normalized. Of course, we can have grades in percentage. Maybe it would have made more sense than uh, grade grade squared. But let's do this. Grades, and we can pick the grade column, right? And we can then divide it by 100. Right? Now, if we run this, and instead of grade samples here, because if we still take our grade sample, you're going to see that our grade does not yet have that null that we have, right? So what we are going to do, we are going to, excuse me, we are going to copy this, and I'm going to take another sample from here and say results instead of results. Right? Can you see that now we have the different results from this one? True, which is we have the past column added, the grade square. I'm not sure how this makes a lot of sense, but we now have the normalized, which is we have it in like a decimal format, which might be something you are interested in. And why is it better to always do these results is that it doesn't mutate your original data frame. So we still keep the data frame as it is. Any question? All right. Okay. Let's go to see this apply in, excuse me. Another thing you might be wondering here, okay, this is another area where I should come in, is that you remember that if you look at let's do learn results, learn grades, right? And what I'm just going to do, I'm going to put this in a print, right? As you can see, we have this particular grade, but let's see how does this our result undo the null grades. How does it undo? At least we know that the grade ID is null here, right? So I can filter here. I can say display results, and I pick results, right? And I go here and I pick grade, and I can say dot is null. And you see that all the nulls have returned null. Now there is a particular way that we can and I don't know if I should take this down or push it to the to okay, let's push this to another 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 time. Let's just put it to another time. Let's see. I was thinking because what I wanted to do, it will require me bringing in the numpy the numpy the numpy library, and I don't want to go into numpy today. Let's quickly see how this our this what we have done in pandas now, how will it work also if we were to run this in say excuse me in say uh PySpark, for example. So we can run this and say from PySpark from spark dot from PySpark from PySpark dot SQL dot function, right? John, you can't see my screen. Can any other person see my screen? Import. Okay, okay. John, I think it may be your network. And I'm going to import column when and delete. And this is so I'm going to say Spark grades. I'm going to set it equal to spark dot read dot csv, right? And we're going to pass in this particular csv, the URL. I'm going to pass this in. Oh, what did I just do? Control Z. I need to do the copying. Let me just copy from here. I think it's faster. And of course, because this is Spark, we need to tell it that the first role is the header. Header equals true. Otherwise, we are going to have column name C0, C1, C2, C3, C. I think because we have 4 columns in the original, we just have 3. We have C0 to 3. In fast schema, we are not in production, so this is fine. And I will keep on saying this as we are learning tutorial. In fast schema, it's not something you should do in production. This is kind of like, don't do this in real life. Now, it's not like if you do it, it's going to break your pipeline. No, actually, it might break your pipeline, but it's like some of those practices that can slowly allow bad data creep into your this thing. You know that when the data frame engine is confused as to what data type you are dealing with, a lot of time it's just going to default back to string. and you want to catch that issue earlier. You understand? So you don't want to infer schema. You want to always know what your schema look like. In fact, in some cases, you even want to bring in struct fields and make sure everything goes the same way you allow, because again, it's production, right? You can make sure everything is working fine and everything is stable. So you don't want your this thing to be deciding for you. You want to be in control. True. Right? So in first schema, we say is true. Now, of course, we can see what Spark grades. Which one? Oh, functions. Sorry. Should be functions, not function. Alright. So we can see what Spark grade is going to look like. So we can say display the Spark grades. So we run this way, and here we are. We have the column. Now, if we want to add an additional column in Spark, how do we do that? Let's add one column, and we'll do this. We'll do this with in place, and okay, let's do this first. Let me do the one with where we assign it in place, which I say always be careful. Don't, if we want to do the direct assignment, we will just do Spark grades, right? And we can set it equal to, right, Spark grade dot with column. That's how you do a derived column in Spark. And I'm going to call the name of the column passed. Is that what we call the initial one? Just, yes, passed, right? And we are going to say passed, and we'll just pick the conditioner, which will be call and grade greater than or equal to 50, right? So if we were to run this now, let's run this and see what we get. Oh, sorry. If we now display, let's display Spark grade. Okay, to see something. And if we run this, we'll see if someone passed. Passed is true or false. What if we want to add some maybe we want to add a conditioner, like a case statement, right? Again, we can say, let's say we want to see if the score is high, if it's low, if it's in the mid level or so. We can do a conditioner in Spark. Let's add a conditional column also, like a derived column, but it's working with a conditioner. We can do the same Spark grade, and set it equal to Spark, right? Spark grades, and we can do with column, right? Can do with column. Sorry, this will be with column. Right, and we can now have this column called tier, right? And tier, we can now have the conditioner. Remember, we've brought in when, so we can use when here and say when when always ends with otherwise. So we can do when col grades is greater than or equal to 70, or we have the comma, what it should return. Let's say hi. These ones are the ones that really came to school to study. Okay, I can do hi. Let's just call it hi. And then can have another. In fact, we don't have comma. We'll keep on chaining here. So we'll do dot when again. When you can actually write it immediately at the back, just that it makes it neater. So I could write. In fact, let me write it that way first, and then make this neater so that you can see this thing dot when call and grade, right, is greater than or equal to 50. It's greater than. Okay, let's make this neater. Let me give space. 50. These are the people that they are in school. They are just trying their best. These are mid-level students that at least they are showing up. Then we put otherwise. Now, if you know case statements in SQL also, this is exactly what it is. Case. This is case. When this, when, then. So when, then, and then else. But in this case, it's just different naming for this thing. Otherwise, we are going to say that is low. So anything that is below 50 is already low, right? Now I said we can write this way, make it neater, so that you can just come in and if we run this, we're going to see that tier will now be added to our Spark grade. Remember that Spark grade does have this, we added past before. And this approach, why, I mean, I have to teach it anyway, but I don't really like it, is that it mutates the original Spark grade, right? Because a lot of things are now and in reality, it's a new data frame entirely. Because remember, class 1, data frames are immutable. So it's a new data frame that gets assigned, is more like a new data frame overwriting the old data frame, right? Which is not what you want to do. So you first create a data frame, then you overwrite another data frame, which is just like you're deleting the old one. And you can see that these two derived columns are now here, tier and this. Now what you can do is to you can do what I like to do, which is to do results like we did before. So we can do, what's this one that we did earlier? Let's see. Here we did results. And here, because we call this one results, I'm just going to call the next one results. Right? So I'm going to say results is equal to Spark grades. We did square and which one did we do the other time? We did squared and normalized. Okay, we've done pass, right? What I'm going to do is I'm going to okay, let's even have whatever is already here, so that we have the tier and everything, assuming that is it. And I'm going to do dot select. Right, and I'm going to say this is another way of doing things, especially when you want to do uh, multiple, right? And I will say dot select. First, I'm going to select star. So this is an expression, right? So that will bring all the columns in this pack grade for me and assign it to result. But then I want to do alias, right? I want to pick certain columns, do some transformation on them, and return them with another alias. So what I'm going to do is that after I've selected everything, just going to say, then I will do col, right? And I will say uh, grade, right? Divided by 100 in this particular case. And I'm going to give it an alias, and I'm going to say normalize this. Grade normalize, right? Alias grade normalize. Don't worry about this ruling offline. I don't know why it keeps doing this in my Databricks. I'll investigate later. But that syntax is actually correct. So worry not about the just ignore it for a moment. That's if you can. Great. Right. And I'm going to do the square here for each of the rows. And I'm going to alias this as grade squared. Right. And I'm going to say grade squared dot alias and we can do grade squared and I'm going to run this now. And if we display results, we are going to see, you can see that we now have the normalized and the squared and all the other important departments that we have there, right? So this is one way of doing the same thing. You can do with column or you can do select, especially again different ways, the same uh, the same results, different ways, the same results, different way, same results. Now there is even another way that you can, even if you really like SQL, right? Spark has this expression, this thing, just like we have in pandas.query. Spark also have this. So let's say results. Let me do results. Let's say 2. Let me just do results 2. And I can do this and say this results 2 is equal to Spark grades, Spark grades underscore dot select expression, So EXPR, right? And yeah, we can now write the query like we are writing an SQL expression without the from clause, because the from is actually the data frame. So similar to what we've done before, I'm just going to write this and select star, right? And then we are going to do every other thing that we want to get. So I can say grade divided by 100, right? As what did we call it again? Grade normalized, right? Let me try and copy it from here. So that is the same as grade normalized. And we can have in fact, let's rerun this so that I put tier inside this place. So I'm just going to rerun this one, because if I run this now, it would have had all those tier and passed here. So what I'm going to do, I'm just going to rerun this data frame so that we get a fresh one, and we have it as it is. So, and because we are doing results too, we are preserving the old one that we have. So I want us to be able to do this, and I'm going to add so I will do comma, that's grade normalized, and I can do grade squared and say grade star 2, or star 2 will actually not work in SQL, because remember it's an SQL expression. So what we are going to do, I'm just going to do grade times grade, right? And I'm going to say as grade squared, and we can now write, and this is the exact reason why I want us to come and do this normalized. We can write a case statement straight up here. You can say case when grade is greater than or equal to 70, then high. And always be careful how you use your quote. Double quote outside, single quote inside. Single quote outside, double quote inside. Don't mix the two up. Just be careful. High, right? And I can continue and say when grade is greater than or equal to 50, then mid. I will now say else low, right? And I can say end as, let's just maintain the convention, tier. Then I can run this now and get my grade. So what I can do, let's display results too, or whatever name you call yours. We can see that it's almost the same thing, right? albeit the arrangements are slightly different. But again, this is to tell you that it doesn't matter what you it doesn't matter what you put, it will actually, how you do it, it will work. So adding columns is very, very fine. Any questions so far so good?
So can you scroll back up a bit, sorry, to this last expression? Okay, so my question is, what if we don't want to assign these new columns now to like a variable?
It will override the existing one.
Okay, like if we, for example, now if we remove that result underscore two is equals, and we just say spark grades dot select, so we then add everything,
Nothing
is it
gets
possible that?
nothing gets happen. Nothing happens.
Mhm.
So it will run something. So let's see what's going to happen, because this is a select expression. If it was just select now, right, we could display that one, right? So if you run this now, it doesn't change anything, right? Except you want to put it in a display. So it doesn't break anything, doesn't spoil anything. Display, right? Display. It doesn't spoil anything at all. Do you get? You still get
Oh,
this, right?
yes.
Yeah, you can put it in a display because it's a data frame that you're assigning to something. So if we then do Spark grades, you will see that Spark grades will still maintain the way it is before. All right? Do you see? So that's what will essentially happen. So nothing, it doesn't spoil anything, it doesn't break any code.
All right, so thank you, sir.
You're welcome. Another thing we can do, and maybe I should even, yes, let me take you to this. Let's say we have our data frame, and I'm going to say our data frame is equal to df. Df is equal to spark grade, right? I'm just assigning spark grade to a new variable, copying it over to a new variable. Now, these are some, you would have, maybe you've had somewhere that they've told you that don't use loop in in this thing. And I used to do this when I first started using Spark, because again that year there was no LLM, very little knowledge. We were one of the first set of people to be using Apache Spark, so there wasn't really a lot of understanding there. So you can see, let's see, let me just try. I want to do one. Okay, let's write a for loop. You can say for I in range, range 20, for instance, right? And I can see df is equal to df dot with column, right? And I can say an f string, and I can put this f string and say uh, derived underscore I. And we can now do the expression we are looking for, so that we know the this thing and we say column grade times whatever is inside the I times I, right? And so if I run this now, this is a very terrible query to run actually. I mean, for a very small something, you may not see it. If I do df dot explain, we see the over 20 step query plan. You know that this my query has not actually run, right? And we see the this is the query plan and the different steps that it will go through. That it will go through. It's crazy. This is a lot. You understand? But and we can look at it and see display df, which we call that our I keep spelling display wrong, right? I mean, in a small this thing like this, you won't notice, right? In a very small data frame like this, but Spark is not built for a very small data frame. So if you are using Spark, chances are that you are dealing with very large amount of data. And if you go and make that mistake, you are going to have like a you're going to have issues on your hand, like your query performance is going to lag. What you should do, or what we can do, all right, now let me show you what the best approach is to do is to put it in an expression. So what I'm going to do, I'm just going to say expression, and I'm going to set it equal to uh I'm just going to put it in this, and I'm going to do a list compression, and follow me as I do this code. I'm just going to do grade, right? And grade times I, and I'm going to alias it as dot alias as we did earlier, all right? And I'm going to say derived um dot alias, and I'm going to let me make sure I just copy this one that we have here. Derive, and I can copy this f string, can come back and put it here, right? And can now say for I in range 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 20, and I can now reassign my, let's do df is equal to spark grade. I'm reassigning the df now, grades dot select, and I'm going to select star. Then I'm going to add the derived as expression. I'm just going to do star the data this same name expression, and if we run this now, let's do df dot explain so that you see the difference. Explain in this case. It is just a minute. Expression is looking like photon plan. The expression is supposed to be actually supposed to be lesser actually. Photon columnar to row, columnar to row. As derived, as derived. It's actually doing the same thing actually, which is crazy because of this photon acceleration stuff. Okay, maybe I'll dig into that and probably put it in another class. We'll look at what could be responsible for that. I think this is a good place to stop for today. If I don't know if we have questions. I think since we've started doing this our YouTube sessions, questions have been lesser than they used to be in the real life sessions.
Okay, Mr. Allen, can we just, I don't know, that derived part of using those two loops, I'm new to that. Even if I think you can scroll this, I'll just take a screenshot and just,
You
tell
can
me how to
always
code
go
it.
back to YouTube to go and watch some of this stuff.
So avoid that because I did that 2 days ago. Yeah, no problem. I'll do that, sir.
No problem. But again, I can scroll so that if screenshots, what are the benefits of being in a live class if you can't take screenshots?
Okay.
This one, right?
No, not this one. The one we use the loop.
Okay, okay, okay.
Yes, definitely. Yeah, okay, thank you, sir.
You're welcome. Okay. I don't know if we have questions. Okay, if there are no other questions, thank you very much. It's been Breakfast with Data. I look forward to seeing you in another one. That will be next week. Enjoy your weekend. Thank you.